Hello and welcome to this second video, which is explaining how we look at Kirchhoff's laws in the context of a circuit and how we apply it. Again, I'm going to assume that you are comfortable with the basic ideas of Kirchhoff's laws, and particularly going to focus on Kirchhoff's second law. So let's get started. Let's imagine we have a loop like this. Now this is a loop which has been extracted from a circuit. You can see there's a bit missing there. You wouldn't normally find this. But we're going to pretend that we're looking at this loop and we're interested simply in setting up the equations. Now, as you know, Kirchhoff's second law is all about adding together potential differences in EMFs. We've got three EMFs, E1, E2, and E3, and we've also got four resistors and therefore four potential differences. So our equations are going to get quite messy here because we've got a lot of components, but I'd just like to show you how they're put together. Let's go for it then. Firstly, we need to define our potential differences. Well, they're given by our Ohm's law, which is simply V equal to IR. Okay, the current multiplied by the resistor. And you notice here that we've got different currents going through our different resistors. We've got current 1 going through R1, I2 going through R2, I2 also going through R3, and I1 also going through R4. So we're just being careful with our letters there. We then need to put together the equations looking at our EMFs and our potential differences. Now, when you're doing this, you have a decision to make, which is to what direction you would like to go in. And normally, what you would do is you'd say, well, I'm going to try and come out of the positive terminal of a battery and back in through the negative. This situation is slightly complicated by the fact that we've got three batteries or cells here, two of which are connected in the same sense, but one of which is opposing. And so therefore, we've got a slight complication there in terms of our direction. It's not quite so straightforward. Okay, so let's try two different directions. We're first going to go in an anti-clockwise loop. We're going to start from E1 and we're just going to go round and we're going to look at the EMFs and potentials. You notice that in our anti-clockwise loop, E1 and E2 are connected positive to negative, and therefore what they're going to do is they are going to add together. E1 and E2 are going to add together. If we just avoid R1 and R2 and go straight down to E3, we can see, however, that E3 opposes E2 and E1. And the effect of this is that it becomes a negative value. As we're going around our loop, you can see that as long as we are coming out of a positive terminal, then it's going to be positive. However, we're going into a positive terminal, then it becomes a negative value. And so therefore, just look at the left-hand side of our equation. Our two EMFs at the top will add together. However, our EMF at the bottom will take away. Effectively, this is an additional potential difference. It's opposing the current flow as it is being pushed from E1 and E2. We also have to worry about minus signs on the currents, and I'll talk to you a little bit about why that is just now. And you've noticed that as we go through the loop, if I'm going through R1, for example, my loop is in the same direction as R1, as the current through R1, I1. I'm moving down through the resistor and the current flow has been decided as being down as well. However, as I go through R2, I'm going in the opposite direction to I2. And so therefore I2 is written as a negative number. Similarly, for I2 going through R3, I'm going up, I2 is going down, and so therefore it is also written as negative. Thankfully, as I go back up to R4, I'm going in the same direction as I1, and so therefore I'm back at my, and therefore it's a positive number, and I'm back at my E1 again. So the point here really is that if you are going in the opposite direction to the current, it becomes negative. If in the case of EMFs, you're finding that you're entering a positive terminal on your course around your loop, then you're also going to be negative. So it's something to watch out for, and it sounds like a fairly arbitrary sort of silly thing to worry about, but actually it does really influence all of the science that you're doing here. Now we could do this as a clockwise loop, an anti-clockwise loop. We can also do it as a clockwise loop. Okay, in that case, our values simply take the negative. Okay, so we can go round and we look at our E3. E3, well, as we go around our clockwise loop, we're going to come out of the positive terminal of E3, and so the E3 becomes positive. However, as we enter into E2, we enter into E2's positive terminal and also into E1's positive terminal, and so therefore these two values become negative. As we go through the loop, we start to oppose I1, and we start to go in the same direction as I2. And so you'll notice, if you compare the two equations, top and bottom, you can see that wherever I've had a plus sign before, I've had a minus sign in the second equation. Now this has to happen because these two equations have to give the same values. It's not possible for one of those equations to give a different answer to the other one. And so therefore what you can see here is that the equations are essentially exactly the same. They're simply different by a factor of -1. If you're feeling a little bit sort of confused by this, just take, I think the best course of action is to take things very, very slowly and to follow the sort of ideas that we've gone here. If you are opposing the EMF, if you're opposing the EMF or the current, then those two things become negative. And it's one of those things that if you think too much about, okay, then you will start to get quite confused by. However, if you simply accept the rules as a kind of mathematical consequence, these come from our conservation laws, then you will get used to them and you'll find them much easier to practice. As ever, please do let me know if you've got any questions. I'm really looking forward to hearing from you.